Hi students, today we will discuss about Cauchy's second theorem on limits. Now coming to the statement, so an is a sequence such that an greater than 0, which means a positive sequence, and limit n tends to infinity, an plus 1 by n is what? L, which means an plus 1 by n converges to L. Then we need to prove that limit n tends to infinity, an whole power n by n equal to L. Now coming to the proof, so let an be a sequence, simply a positive sequence. Okay, and he has given that limit n tends to infinity, an plus 1 by an is what? L. Now, so coming to the definition, so if an is a positive term, positive sequence for all n belongs to natural number, and limit n tends to infinity, an equal to L, then limit n tends to infinity, so arithmetic mean from the first theorem, Cauchy's first theorem, we learnt about arithmetic mean. Since it is a geometric mean, a1, a2 and so on, an whole power 1 by n is also equals to L. So which means this entire sequence converges to L. Geometric mean of the sequence is converges to L. Okay, so from this, now I define a sequence Cn, which is, for suppose it is a sequence, then it is nth term of a sequence. It is a geometric progression. If it is in the geometric progression, we need to find so nth terms clearly, so as follows. Now C1 is what? A1. C2 is what? A2 by A1. C3 is what? A3 by A2 and so on. Cn is what? An by An minus 1. See, how can we write this? So clearly A1, A2, A3 and so on, An are in geometric progression. So from coming to the geometric progression, how to find the nth terms, which is nothing but T2 by T1. So common ratio is what? T2 by T1. So in a similar way, so terms, so first term is what? A1. Second term, how to find the second term? Is A2 by A1. And coming to the third term, A3 by A2 and so on till the nth term, which is what? An by An minus 1. So clearly, so if A1, A2 and so on An are in GP, now Cn is what? An by An minus 1. Okay, now coming to the product of C1, C2, C3 and so on Cn, what we get? A1 into A2 by A1 into A3 by A2 and so on, An by An minus 1. So before term is An minus 1 by An minus 2. See, all the terms gets cancelled. So A1 gets cancelled, A2 gets cancelled, A3 gets cancelled. So till the end gets cancelled. So these are the terms which gets cancelled. So like this. Now finally what we get? An. So that C1 into C2 into C3 into and so on Cn is what? An. So this is the very important thing. Now, so coming to the given value, limit n tends to infinity, An plus 1 by An is what? L. So given that limit n tends to infinity, an plus 1 by an is equal to what? L. Now replace n with n minus 1. So as n value approaches to infinity, now replace n with n minus 1, no problem with this. So why? Because as n value approaches to infinity, n minus 1 also approaches to infinity, both are same, so no problem with this. Now limit n tends to infinity, an, replace n with n minus 1, n minus 1 plus 1 is n divided by an minus 1 is also approaches to L. See, an by an minus 1 is what? Here Cn. So replace an by an minus 1 with Cn. Now limit n tends to infinity. So clearly this is what? Cn is equal to n. So for all n belongs to n. So this is a very important one. Now clearly so we have the term an is greater than 0. Clearly an is what? Greater than 0. So since he has given an is greater than 0 for all n belongs to n, then we can write an by an minus 1 is also greater than 0 for all n belongs to n. So I am taking an by an minus 1. So clearly an by an minus 1 is what? Cn. Now replace an by an minus 1 with Cn. So that what we get? Cn is greater than 0 for all n belongs to n. So now we have a sequence which is a positive sequence. Clearly we have a sequence, positive sequence Cn. So for all n belongs to natural numbers, the first most important one is Cn is greater than 0, and the second one is limit n tends to infinity, Cn is equal to n. So from this, the Cn is a sequence which converges to L, and it is a positive sequence. So from the definition of limit of a sequence, so if Cn is positive and limit n tends to infinity, Cn equal to n for all n belongs to natural number, then we need to write limit n tends to infinity, C1 into C2 into C3 into and so on, Cn whole power 1 by n is also approaches to L. Why? Because so we know that, so from the definition, so if an greater than 0 for all n belongs to n and limit n tends to infinity an equal to n, then limit n tends to infinity, the geometric mean of the sequences is also approaches to L. So clearly in the same way, so for suppose if it is 1, clearly from 1. So clearly here the same for the sequence Cn also, Cn greater than 0 and limit n tends to infinity, Cn is also equal to L for all n belongs to n. For all n belongs to n, it is greater than 0. Then limit n tends to infinity, so the geometric mean of the sequences is also approaches to L. So from the same definition. Now limit n tends to infinity, so C1 into C2 into C3 and so on Cn, we already find that, which is what? An whole power 1 by n is equal to L. So this is what we need to find. Okay students, this is what about Cauchy's second theorem on limits. So please see carefully. So if an is a positive sequence and limit n tends to infinity, an plus 1 by n is equal to L, then we need to find this. So clearly, so if an is a positive sequence for all n, limit n tends to infinity, an equal to n, then geometric mean of the sequences is approaches to L. So this is a very important condition, so have to be noted. So clearly, if it is a geometric sequence, if it is in geometric progression, clearly how to find the nth term? So Tn by, so nth term Tn is equal to Sn by Sn minus 1. Clearly, so these are nothing but sequence has given, so that we need to find the nth terms, which is what, Sn by Sn minus 1. In the same way, so A1, A2 and so on, An, Rn, Gp, so Cn equal to An by N minus 1. So from this we can write C1 and so on till the end Cn. Okay, now the product of this gives the result An. Okay, and then what he has given, limit n tends to infinity, An plus 1 by An equal to L. Now replace n with n minus 1. So no problem with the n value approaches to infinity. Why? Because n, as n value approaches to infinity, n equal to n minus 1. No problem with this. So that limit n tends to infinity, An by An minus 1 is also equal to L. So An by n minus 1 is what? Cn. So limit n tends to infinity, Cn is equal to L. So for all n belongs to n. So clearly, so what he has given, An is greater than 0 for all n belongs to n. So from this I write An by An minus 1 also greater than 0 for all n belongs to n. So from this, so clearly An by An minus 1 is what? Cn. So that Cn also greater than 0. So here Cn is greater than 0 and Cn is greater than 0 for all n belongs to n, and limit n tends to infinity, Cn is equal to n. Then the geometric mean of the sequences Cn is also approaches to L. So I read the same here. So like this. So we already find that C1 and C2, C3 and so on, Cn is what? An. Okay students, so this is about Cauchy's second theorem. Now coming to the problems, we will solve some solved problems. The first one is, so limit n tends to infinity, 2n factorial by n factorial into n factorial whole power 1 by n is equal to what? Fine, we need to prove that. So this limit is equal to 4. So we need to find this by using Cauchy's second theorem. So clearly what he has given, limit n tends to infinity, so an power, so see this, an power 1 by n is equal to L. So we need to find that it is equal to 4. See what he has given, an is 2n factorial by n factorial into n factorial. So if it is true, then so from the Cauchy's theorem, so if limit n tends to infinity, an whole power 1 by n is equal to L, then from the Cauchy's theorem what we need, what we have, limit n tends to infinity, an plus 1 by an is also equal to L. So he has given this, so we need to find from this. So if it is an, then what about an plus 1 is what? 2 into n plus 1 factorial divided by, in place of n we have n plus 1 factorial into n plus 1 factorial. Okay, now coming to the condition, limit n tends to infinity, so an plus 1 by an equal to, so an plus 1 is what here, 2 into n plus 1, which is known as 2n plus 2 factorial divided by, so n plus 1 factorial into n plus 1 factorial into, now in the denominator we have an, so in the denominator we have a1, so I reverse this an, which is n factorial into n factorial by 2n factorial. So reciprocal for this an is what? Reverse this, n factorial into n factorial by 2n factorial. So clearly, so 2n plus 2 factorial, which is known as, I read 2n plus 2 into 2n plus 1 into 2n factorial divided by, for n plus 1 factorial we need to write n plus 1 into n factorial, and repeat the same for this, n plus 1 into n factorial into n factorial into n factorial by 2n factorial. So here 2n factorial, n factorial, so let's cancel. So I am taking like this is, so clearly n factorial is what? N into n minus 1 into n minus 2 into and so on, 3 into 2 into 1. So this is the formula, n factorial. So it is a continuous product of first n natural numbers is what? N into n minus 1 into n minus 2 into and so on, 3 into 2 into 1. So continuous product of first n natural numbers, 1 into 2 into 3 and so on n. The same way I write this as 2n plus 2 into 2n plus 1 into 2n factorial. Why? Because why I am stopped here? Why? Because 2n plus 2n factorial and 2n factorial both gets cancelled. So limit n tends to infinity. Limit n tends to infinity. So clearly limit n tends to infinity. So the remaining value is what? So take 2 common here. We need to get 2 into n plus 1 into 2n plus 1 divided by, so we have n plus 1 into n plus 1. So n plus 1 also gets cancelled. So finally from this, limit n tends to infinity, two is a constant, put it outside. So 2n plus 1 by n plus 1. So clearly from the, so infinite limits, coming to the infinite limits, so numerator degree is equal to the denominator degree. Now we need to take the coefficients, that's all. So 2 into, so the highest degree coefficient here is 2, and coming to the denominator, highest degree coefficient is 1. So n, the highest degree is n power 1, the coefficient is 2, here also n power 1, the coefficient is 1. So 2 into 2 is what? Equal to 4. So that clearly, so limit n tends to infinity, an plus 1 by an is what? 4. From this, clearly limit n tends to infinity, an power whole power 1 by n is also equal to 4. Now the second one, limit n tends to infinity, so 3n factorial by n factorial whole cube whole power 1 by n is equal to what? See clearly an is what? From this 3n factorial by n factorial whole cube. Now so an plus 1 by an. Now limit n tends to infinity, so an plus 1 by an is what? Limit n tends to infinity, so an plus 1, so 3 into n plus 1 factorial by, so n plus 1 factorial whole cube into, so 1 by n, reciprocal for this is, so n factorial whole cube divided by, so 3n factorial. Now so limit n tends to infinity, 3 into n plus 1 is what? 3n plus 3 into 3n plus 2 into 3n plus 1 into 3n factorial divided by, so why I am stopped here 3n factorial? Why? Because in the denominator we have 3n factorial. So coming to the n plus 1 factorial whole cube, so n plus 1 into n factorial. Now n plus 1 into n factorial, n plus 1 into n factorial. So we have 3 n plus 1 factorials. So we need to take this. Now in the numerator we have n factorial whole cube and divided by 3n factorial. So that, so 3n factorial gets cancelled. So n factorial, n factorial, n factorial, n factorial whole cube. So that finally limit n tends to infinity. So we have, yeah, so now take 3 common here, 3 into n plus 1, so 3n plus 2 into 3n plus 1 divided by n plus 1 into n plus 1 into n plus 1. So n plus 1 gets cancelled. Now finally what we have, limit n tends to infinity, so 3 is a constant, put it outside, so 3n plus 2 into 3n plus 1 divided by n plus 1 into n plus 1, which is n plus 1 whole square. Now coming to the numerator, the highest degree is n square, so n into n square. Coming to the denominator, the highest degree is 2. Now numerator highest degree is what? N square, and coming to the denominator highest degree is what? N square. So coming to the coefficients, if numerator highest degree is equal to the denominator highest degree, so we need to write the coefficients final. So the coefficient of n square is what? 9 divided by the coefficient of n square in the denominator is what? 1. So 3 into 9 is what? So 27. Now the last problem is, so limit n tends to infinity n factorial whole power 1 by n is what? Okay, now this can be rewritten as limit n tends to infinity, so n factorial by we don't have exponent 1 by n here, so that it can be rewritten as n power n whole power 1 by n, then only it is said to be an. So clearly an is what? N factorial by n power n. Okay, right. Now coming to the Cauchy second theorem. So limit n tends to infinity an plus 1 by an is equal to limit n tends to infinity an plus 1. We have n plus 1 factorial by, so n plus 1 whole power n plus 1 into, so we have in the denominator an, so reciprocal for this is n power n by n factorial. So that, so limit n tends to infinity, so n plus 1 factorial can be written as n plus 1 into n factorial divided by, so n plus 1 whole power n into n plus 1 into n power n by n factorial. So we have, so n plus 1 gets cancelled, n factorial gets cancelled. Finally what we have, limit n tends to infinity n power n by n plus 1 whole power n, so which can be written as limit n tends to infinity n by n plus 1 whole power n. Now it is known as limit n tends to infinity, so n by n plus 1. So now send it to the denominator, what we get? 1 by n plus 1 by n whole power, so n. So no problem with this. Now limit n tends to infinity 1 by, so n plus 1 by n can be written as 1 plus 1 by n whole power n. So from the limits, so limit n tends to infinity 1 plus 1 by n whole power n, so we have limit n tends to infinity 1 plus n whole power 1 by n, or limit n tends to infinity, so 1 plus 1 by n whole power n, both are equal to e. So finally from this we have 1 by e. Okay students, this is all about the Cauchy second theorem on limits and the solved problems. Okay students, thank you. So please do subscribe, share it to your friends. Thank you students.